Okay, so good afternoon to all and welcome to lecture number 28. And today we'll start chapter number 6. We have covered 4th chapter and then today we are going to start, instead of 5th chapter, we are going to start 6th chapter because this is an important chapter. So I feel that I should cover this chapter and we have this only this week as the last week for instruction. So our 6th chapter is high-level computer vision, in which we will be studying the dynamic scene analysis. So in today's lecture, we'll see the basics of dynamic scene analysis, and then next few lectures we'll study about the different algorithms for finding the motion vectors, and then to find out the algorithms for motions and so on. So this is the 5th chapter which we are not covering, that is high-level computer vision, image understanding, and 3D vision. Okay, and then this is the 6th chapter, that is high-level computer vision, dynamic scene analysis. So this is the last chapter. So in this, basically, we'll be studying estimating the motion vectors using sequential search algorithm, logarithmic search algorithm, and hierarchical search algorithm. After that, we'll study the motion analysis, then differential motion analysis method, trajectory detection, and then optical flow analysis based on the correspondence of interest point, and at the end, Kalman filter method for motion analysis. So I hope that in this week we will cover this chapter, and if required, I will take one extra lecture because I don't know whether I'll be able to finish within 3 lectures or not. So maybe I need at least 4 lectures to finish this chapter. So we'll organize one extra lecture for this one. So in today's lecture, we'll talk about the fundamentals of dynamic scene analysis. So dynamic scene analysis is nothing but basically dynamics means whether there is a change, and you know that in the scene there will be change. You might have seen in the video. Okay, so if you see the video, you see that you get the motion effect in the video, whereas in the case of still image you don't get the motion effect. Okay, because still image is just a single frame, so which is captured a single frame, so you get only the information about that particular scene at that instant. Okay, but you don't get any information about the motion and so on. So this kind of information about motion you will get in the video. So what is video? Basically, video is the sequence of still images or frames. In very first lecture, we have studied the dimension of the signals. Like for example, if you see the speech signal, so speech signal is recorded with respect to time. So your x-axis is time, y-axis is amplitude, and then speech is recorded with respect to time, where this x-axis variable is time variable and y-axis variable is amplitude variable. So out of these two variables, one is dependent variable and another x-axis variable is independent variable. So here, basically, there is only one independent variable in case of speech, and that's why it is called as a one-dimensional signal. Whereas in the image, image is represented in the space, and you know the space coordinates are x and y coordinates, and every junction of x and y coordinate intensity is recorded, and this I is a function of x and y. So there are 3 variables basically. I is the intensity, x is the x coordinate of the spatial domain, y is the y coordinate of the spatial domain. Out of these 3 variables, x and y are independent variable, and I depends upon the value of x, I depends upon the value of y, so I is dependent variable. So in image, basically there are 2 independent variables, so still image is called as a 2-dimensional signal or 2-dimensional signal and so on. Whereas the difference between the image and a video is that video is a sequence of images. Okay, so one image we can consider that as a frame. Okay, and then if you capture those frames with a speed, like for example, as per NTSC standard, if we capture number of frames of that particular scene, like a 30 frames per second, within 1 second, if you capture the 30 frames per second, and if you play those frames with the speed of 30 frames per second, then you get the motion effect and so on. So video is a sequence of still images or frames. Okay, what are the applications of this video? So you might have seen that okay, you get the picture this one in the video forms, or you might have seen that this one the sports events are telecasted by using video, or teleconferencing, or digital TV. And then in entertainment also you'll find these videos, and then education also in medicine or in surveillance and so on. So everywhere you'll find this dynamic scene. Video is nothing but the dynamic scene basically, right? Now there are two types of videos. Okay, in the recording, two types of video recording is done. One is a progressive video recording, and another one is interlaced video recording. Okay, so see that in the progressive video recording, see that this every line is scanned, okay, line by line, right? So see that when you capture the video, basically your video camera scans the scene in the frame line by line. So as per standard, how many lines are there? Okay, there are 625 lines in one frame. 625 lines are there, scanning lines are there in one frame. So these lines, in case of, see that even basically when we see from left to right and top to bottom. So this video recording is also done by scanning the scene. Okay, so video camera basically scan the scene line by line, and total number of lines are 625. And then in progressive video scanning, or in progressive, generally this scanning is done one by one, like as a first line scanning, then after that second line scanning, the third line, up to 625 lines are there, so in one frame. So this scanning is called as a progressive video scanning. So there is no notion of field, or field is group of even or odd. Field is not there in case of progressive. And this scanning lines are spatially adjacent. Scan lines are also called as the also temporally adjacent. So they are spatially adjacent as well as temporally adjacent. And then scan line is the order of reading. Like for example, we read, when you read the book, how do you read the book? You start reading from the top left corner of the book, and then you read the first line. Then after that you read the second line, then third line, and so on, and up to the last this one line of that this one page. And after that you change the page, and then again you start from the top, and so on. So one page, you can see that in one you can correlate that one page in the book is one frame in the video scanning, and so on. So in progressive scanning, you read or you scan line by line from top to bottom, and then once that lines are over, in the next field again you start from top to bottom. So like that way you read the next page of the book, and so on. So this kind of scanning is called as the progressive scanning in the video. Okay, there is no notion of the field. We'll see what is by field and so on. Okay, second type of video is nothing but in video scanning. Second type of video scanning is interlaced video scanning. Now, why we are going from progressive scanning to interlaced video scanning? You know that the line frequency in India, line frequency is 50 hertz, right? Line frequency is 50 hertz. Whereas if you go in a USA, okay, line frequency is 60 hertz, right? So when you are transmitting the video, okay, if this frequency is not matched, if the scanning frequency or scanning rate is not matched with the line frequency, then there are chances that there will be interference in the interference of this line frequency or line frequency in the video. So this is called as the flicker noise basically. So to avoid the flicker noise, instead of doing the progressive scanning, interlaced video scanning is done. Now, how it is done basically, the frequency of this one is matched with the line frequency. Now see that what is done basically in case of this one. Uh, uh, okay, in interlaced video scanning, in interlaced video scanning, basically what we do, we scan this one. One line first, this one first odd lines we scan like as a first one, then third one, and then after that fifth one, and then seventh one, and then ninth one, and then so like that way odd lines are scanned, and then this one after all lines are scanned. Now, as I told you that there are 625 lines. So 625, if you divide it by 2, there will be how many lines? 325, 312.5. So 312.5 means this first scanning will be over at the center here, basically 12.5, right? So this one, it will scan first one line, then third line, and then 625th half line will be scanned. And then after that, second field will start, okay? And remaining even scan lines will be scanned, like a second line, third, fourth line, sixth line, and up to remaining 6.5 line and 625 and half line, and so on. So like that way, in case of this one, see that in case of interlaced scanning, we scan in the field like as a top field and a bottom field, and you know that number of frames, okay, number of frames as per NTSC standard are this one 30 frames per second, right? 30 frames per second. I was correlating that one with the line frequency. Why we are going for this interlaced scanning and so on. So just to avoid the flicker noise, we would like to match the rate of the scanning just like as the line frequency rate and so on. So how it is done now here, see that in interlaced scanning, as I told you that in a video, basically in NTSC standard, there are 30 frames per second are there. So in 1 second, there are 30 frames, right? So this is your complete frame, right? Now, how many frames are there in one frame, 1 second? There are 30 frames, right? But, okay, whereas in case of PAL standard, okay, there are 25 frames per second are there. So in PAL standard, there are 25 frames per second. Now, you know that in India, the line frequency is 50 hertz. Okay. Now, if this one frame is divided into odd field and even field, okay. So in one frame, how many fields are there? One is odd field and another one is even field. Odd field will scan odd lines 1, 3, 5, 7, and so on. Even field will scan even lines. So in one frame, there are two fields. One is odd field and another one is even field. Okay. Sometimes odd field is called as the top field and even field is called as the bottom field, right? So in one field, in one frame, there are two fields. So how many such frames are there in PAL standard? There are 25 frames. Okay. So how many fields will be there? There will be 25 into 2, because in every frame there are two fields. So how many fields will be there? There will be 50 fields, and these 50 fields are matching with the 50 hertz line, and this avoids basically the flicker noise in a case of Indian scenario. Whereas in case of USA, okay, line frequency is 60 hertz, so they use the NTSC standard. In NTSC standard, number of frames per second are 30. So in every frame, there will be two fields. So total number of fields will be equal to 60. So this 60 is matching with the 60 hertz, and that avoids the flicker noise. So to avoid the flicker noise, particularly this interlaced video scanning is done, where each frame is composed of two fields. That is, top field is nothing but the odd field, and bottom field is nothing but the even field. So spatially here, basically, when you are doing the spatially this one, you are doing the scanning of first line, and then after that you are doing the scanning of third line. Then this one, fifth line, and so on. So this is not spatially adjacent, but they are temporally adjacent. So first and third is temporally adjacent, but they are not spatially adjacent. In a case of basically progressive scanning, what we have done, we have scanned first line, then second line, third line. So they are spatially and temporally adjacent, right? But in case of interlaced video scanning, okay, this one, spatially adjacent scan lines are not temporally adjacent. That is, bottom fields are scanned after all the top fields in the frame are scanned. So at 30 frames per second, the adjacent scan lines are 1 by 60th of the second apart. So like that way, this is the time difference between the adjacent scan lines and so on in case of interlaced video scanning. I hope that you have understood the concept of odd field and even field, as well as progressive scanning and interlaced video scanning. And also you might have understood why interlaced scanning is used. Generally, this one, to avoid the flicker noise, interlaced video scanning is used. And you know that the standards which are used in India, PAL standard is used, where in 1 second there are 25 frames per second video scanning rate is there, whereas in USA so this one NTSC standard is used, where a number of frames are 30 frames per second, right? So now generally see, when you are transmitting the information from one place to another place, like transmitting the program, you cannot transmit that program as it is, because it will need a lot of memory, as well as it will need a lot of bandwidth. Okay, and you know, you must be knowing that. So for example, if I'm standing for 1 second, and if the camera is there and which is capturing the video like frames per second, so in 1 second, if I don't move for 1 second, so 30 frames will be same frame. So that is nothing but basically we can say that there is a temporal redundancy, like first frame is just like a second frame is just like a third frame is like as a fourth frame, and so on. Now sending such redundant frame is of no use, so you have to send the important frames so that it will reduce the bandwidth, as well as it will reduce the memory requirement, and it will increase the speed of transmission also. So in video coding, basically, temporal redundancy is removed. What is by temporal redundancy? Basically, if two frames are having same information, like for example, as I told you that for 1 second, this camera is capturing a video of me, and if for 1 second, if I don't move, okay, so like this. And the number of frames in 1 second will be like, as per PAL standard, there will be 25 frames will be there. Now, if I don't move, if I don't talk and so on, so all those 25 frames will be having same information. So this information, like frame 1 will be same as frame 2, frame 2 will be same as frame 3, and so on. So all those frames will be having same information, that is redundant information, and this is called as the temporal redundancy. Whereas spatial redundancy means, okay, if all the spatial pixels, okay, all the pixels are having the same information, then that is called as the spatial redundancy, and so on. So you have to remove the spatial redundancy, as well as you have to remove the temporal redundancy in a case of video coding, and then you can transmit the program. So motion estimation, or even for dynamic scene analysis also, okay, you have to do the motion estimation and compensation for temporal redundancy removal, and so on. And particularly for that one, discrete cosine transform okay, is generally used for spatial redundancy technique. So you might have studied this one in the compression chapter of image processing, that which you have studied in the first semester of your master's program. Whereas VLC coding is used for statistical redundancy reduction, and so on. Then you must be aware of the quantization, that is, it ideally exploits the characteristic of human visual system, HVS, to mask redundant information in order to reduce the data, and so on. Now, video compression based on the motion compression, you must be knowing that. So just okay, for your understanding purpose, I'm taking this one. After that, okay, we'll be talking about the motion estimation and motion vector estimation, and so on. But this is used in dynamic scene analysis as well as in video compression. So you know this static compression, like for compression of the static image, the standard which is used is nothing but the JPEG. And in JPEG, okay, JPEG 2000 is the standard for compressing the static images, and this exploits the spatial redundancy. So it removes the spatial redundancy. You must be knowing about this JPEG 2000 architecture and so on. Whereas this one for video coding, okay, either H.261, 262, 263 is used, or MPEG standard is used. So one of the actually 50% part of the MPEG or H.261 is similar to the JPEG, and only the motion composition part which is added here in the MPEG or H.261 that adds spatial redundancy removal as well as temporal redundancy removal and so on. So you get the this one video, compressed video and so on. So video can be viewed as a sequence of images stacked in the temporal dimension, and temporal redundancy is nothing but, as I told you, that since the frame rate of video is often relatively high, that is greater than 15 frames per second, and the camera parameters like as the focal length, position, viewing angle, etc. okay, yeah, is there. So usually do not change generally, and do not change rapidly between the frames. Like for example, between two frames your focal length will be same, position will be same, viewing angle will be same, and if there is no motion, basically if there is no change in the background, or this one object is not moving, then your first frame and second frame will be same. So the content of consecutive frames are usually similar unless certain objects in the scene moves extremely fast. Okay, so if the two consecutive frames are same, then that is nothing but the temporal redundancy. So temporal redundancy is often significant and in dynamic scene analysis, and it is exploited basically, okay, particularly for video coding. So not every frame of the video needs to be coded independently as a new image when you are doing the video coding, but only the motion part you can encode, and then you can send that one. So that will really save memory requirement as well as bandwidth requirement, and it will be fast for transmission and so on. So you don't have to encode every frame. You have to remove the temporal redundancy, and then only the motion part which is there, that you have to encode either by using MPEG standard or H.261 and so on. So difference between the current frame. Now what is meant by motion? Motion is like, for example, if I'm standing, okay, or if I'm sitting, and then for 1 second, so all those 30 frames or 25 frames will be same. But if I move my hand, okay, so in 1 second, how many frames you are capturing? You are capturing 30 frames. Like for example, in my first frame, my hand is here. In my second frame, my hand is here. Third frame, hand is here, and so on. Now, the difference between the first frame and second frame is that now first frame was having hand here, and second frame was having hand here. Now, at that time, rest of the portion was same. Only thing is that this hand was moving from this position to this position. So, what is the difference between first frame and second frame? So if I just subtract the first frame and second frame, I'll get only the information about the motion. So the part which is moving, that will be different as compared to the rest of the part, and so rest of the part will remain same. So since it is same, difference will be 0, and the part which is moving, so there will be difference, and this difference will give the information about the motion, right? So difference between the current frame and the other frames in the sequence is coded, so that the difference you can encode and then transmit in case of video coding and so on. So if the redundancy between them is great enough, if temporal redundancy is great, then difference will be of small values. Like for example, if first frame and second frame is same, then definitely difference will be 0. Redundancy is more in that case. And okay, and if this is small, like a difference is small, it will have the low entropy, which is good for compression. So you can achieve more compression in that case and so on, right? Now, simple way for deriving the difference image is that how do you find? just subtracting one frame from the another frame. As I said that in the first frame my hand is here, in the second frame my hand is here. So for first frame and second frame I'll just subtract, and what I'll get, I'll pixel by okay, we'll subtract that pixel by pixel, and what we'll get, only the this one information about the motion. So subtract one image from the other pixel by pixel. But what is the disadvantage of that one? Such an approach is ineffective in yielding the high compression ratio. Okay, since the main cause of difference between frame is camera and or object motion, and these motion generators can be compensated by detecting the displacement of the corresponding pixels or regions in these frames and measuring their differences. Okay, so video compression algorithms that adopts this approach are said to be based on the motion compensation. So instead of simply deriving the or finding the motions by using subtracting one frame from another frame, we can find the motion vectors or by using motion compensation algorithm, and then that will yield better compression as well as better detection of the motion and so on. So motion, what is meant by motion compensation? So there are three main steps of these algorithms. One is motion estimation, that is finding the motion vectors. So in this finding the motion, okay, in finding a motion estimation, we will study three algorithms. One is sequential search algorithm, another one is logarithmic algorithm, and third one is hierarchical algorithm. So this we will do by studying this one, and then motion compensation based prediction, and then after that derivation of the prediction error, that is with the difference. So particularly we will study these algorithms in detail, and then after that we'll see what is motion, and then how motion is calculated by using simple difference method, how motion is estimated by using optical flow method, and so on. So like that. This motion, motion compensation, this one. Motion estimation is done by using or by finding the motion vectors. Now, what is my motion vector and so on? So we will see the basics of this estimating the motion vectors. Now, when you are estimating the motion vectors for doing the dynamic scene analysis, for that what you have to do, for efficiency, each image, that is nothing but each frame, is divided into macro blocks of size n by n. This whole frame is divided into a small blocks, which is called as the macro block. Like for example, the size of this n is 16 by 16. Like for example, if your frame size is 256 by 256, so entire frame of 256 by 256 is divided into a small micro blocks of size n by n, where n is 16 for luminous images and n is 8 for chrominous images. For color images, it is 8, right? And for luminous images, it is 16 grayscale images, and so on. Right. So what will be the number? How many number of blocks will be there? In the case of if this one, the frame size is of 256 by 256, so number of blocks will be macro blocks will be equal to, see that the whole image 256 by 256 is divided into small blocks of size 16 by 16. So there will be how many blocks? So 16 into 16, that is 256 macro block will be there in every frame. If frame size is of 256 by 256, right? I hope that you have understood the concept here. Okay, what we are doing, we are first dividing the frame into a macro block, and the size of macro block is n by n. This n is 16 for luminous image, and this n is 8 for chrominous image. So motion compensation is not performed at the pixel level nor at the level of video object, but it is done at the macro block level. Now here we are trying to find out the match between, instead of entire image, what we are doing, we are, see, instead of finding motion in the entire image, we are finding the motion in the small area. This small area is called as the macro block, because see that when you when object is moved, like for example if my hand is moved, so it is moved here only. It's not like that, okay, I'm moving hand here or something like that. So definitely we have to search the area which is just adjacent to the earlier macro block and so on. So this will basically reduce the searching time, and we'll get the more efficient algorithm to find out the motion vectors and so on, right? So motion compression is not performed at the pixel level nor at the video object, okay, but it is done at the macro block level. Like for example, you are finding the motion vector between two macro blocks, right? So object may be moved here either in this direction, this direction, this direction, this direction, or this direction. So you have to just search the motion vectors which are adjacent to the that macro block, okay, and so on, right? So the basic terms which are used for motion compression are: the current frame is referred as the target frame. Like for example, current frame is referred as a target frame, and where motion you are estimating, that is next frame. Either you can estimate the motion okay, of previous frame or next frame, okay, because you are finding the match, okay. So current frame is considered as a target frame, and the next frame or previous frame is called as the reference frame. So now what we are doing, like for example, object is here in this frame. Now this object may move here. So we are trying to find the match between this one and this one. So match is sought between the macro block under the consideration in the target frame and the most similar macro block in the previous or future frame, that is called as the reference frame. So there are two concepts. One is target frame, another one is reference frame. Target frame is nothing but the current frame which is under consideration, and you can find that object, okay, either you can predict from the future frame or you can predict from the previous frame. So this future frame or previous frame are called as the reference frame, whereas the current frame is called as the target frame. So I hope that you have understood what is meant by target frame and what is meant by reference frame. Okay. So the target frame, macro block is predicted from the reference macro block and so on. Right. Now, another basic terms which are used for finding the motions is nothing but the motion vector. So what is meant by motion vector? See that the displacement of the reference macro block to the target macro blocks. Like for example, object was here, okay, in a target macro block, and it is moved in the reference block, next block to some other macro block. So definitely all the pixels of previous macro block in the reference target one will be matching with the reference one. So this object is moving in this direction, like for example. So the displacement of the reference macro block to the target macro block is nothing but the motion vector, right? And then what is by forward prediction? In forward prediction, basically the reference frame is taken to be as the previous frame. Like for example, previous frame is considered as a reference frame and target frame is the current frame. So you are predicting, okay, so in forward direction, the reference frame is considered to be as a previous frame. So in that is nothing but the forward prediction. And in backward prediction, the reference frame is considered is a future frame. So future frame. So from future frame, okay, you are using the future frame as a reference frame for prediction of the target or finding the motion vector. So that is nothing but the backward prediction. And then prediction error is what? Prediction error, see, like for example, the whatever the predicted motion vectors are there from target and the target frame and the reference frame, if there is an error, okay, or if there is a difference, so the difference of the two corresponding macro block is called as the prediction error. Okay, so here we have seen some fundamental terms which are used particularly for motion estimation. One is the target frame. Target frame is nothing but the current frame. Reference frame may be either future frame or previous frame, right? Then we talked about the motion vector. Motion vector is basically the displacement of the reference macro block to the target macro block. So this displacement will give you the vector, and that vector is nothing but the motion vector, right? So displacement of the reference macro block to the target macro block is called as the motion vector. And in another term which we talked about is forward prediction. So in forward prediction, the reference frame is considered to be as the previous one, whereas in backward prediction, reference frame is considered as the future frame. Okay. And prediction error is nothing but the difference of the two corresponding macro block between the target frame and the reference frame. So this difference is called as the prediction error. If reference macro block and target macro block is basically exactly matching, then there will be minimum error. But if it is not matching, then there will be error, and that error is called as the prediction error. So these are the terms which are used for estimating the motions and so on. In tomorrow's lecture, we will talk about sequential search algorithm, we'll talk about logarithmic search algorithm, and then we'll talk about the hierarchical search algorithm to estimate the motion. So today we'll stop here, and then tomorrow we'll continue with the motion estimation by using different algorithms. So thank you very much.